Now, starting with circular motion, right? We know that distance has the formula speed times time, or velocity times time. Velocity times time. Now, distance in the second year physics is known as something called angular displacement. In circular motion, it's known as angular displacement. So instead of d, I would write this sign right here, or something like this, which means angular displacement. Now, angular displacement is equals to the velocity or speed, and velocity in this chapter is called angular velocity, and it has a symbol of w. This is also known as omega, right? So velocity is w, distance is this symbol right here, or angular displacement, and time is simply t. So angular displacement is equals to angular velocity times time. And this formula right here, which states that time equals to the angular displacement over velocity, or angular velocity. Because when I want to find time, I'll move this omega to the left, it will go down, and I'll get this formula right here. So this is one formula that you need to know. Now, the second formula is the formula for angular velocity, this formula right here, which states that angular velocity equals the distance, which is 2 pi. Why is it 2 pi? Because in a circle, right, in one complete circle, the distance traveled, or the circumference, is 2 pi. So the distance is 2 pi and the time is t, capital T. What is capital T? Capital T is the time period. What do I mean by time period? Time period is the time taken to travel one complete circle, right? So one complete circle takes this much time, or capital T. So I know that time period, right? Time period has the formula 1 over f, 1 over frequency, right? So instead of writing t, and when I want to write the f as the subject, right? So I want to make frequency the subject. So I'll write f equals 1 over t, right? So now I know that t can be replaced by 1 over f. So when I simplify, right? When I simplify, I get 2 pi f. Omega equals to 2 pi f. And this formula right here is another important formula you need to know. Now, coming to this thing right here, velocity is, I know, distance over time. So distance is 2 pi r, and time period t is capital T. And I also know that omega is 2 pi over t. So from this, I get this equation, which states that V is omega r, where V is velocity, W is angular velocity, and R is the radius of the circle. So this part right here is also very important, which states that acceleration, right, is velocity square over radius. This is another important formula you need to know. And velocity, I know, V, I know, is r omega, right? So when I go to this formula right here, instead of writing V square, I can write A equals to omega r whole square over r, right? I can write it like this as well, because V is omega r. V is omega r. So when I do that, this omega gets a square and this r also gets a square. So A would become omega square r square over this r right here, which is like this. So I can cancel r and the square, and I get another formula, which is A is omega square r, or A is omega square r. Now, if someone wants this notes, you can ask on Discord. I'll share these notes. These are my personal notes I made for A level. So this will really help with the IMAT as well. So going ahead, force, right, is mass times acceleration. Now, I know force is mass times acceleration. So I write F equals to m mass. And instead of acceleration, right, instead of acceleration, I can replace A with this formula right here, V square over R. So when I do that, when I write V square over R, because instead of writing MA, I can replace this A with V square over R. So when I do that, I get this important formula, which states force equals mv square over R. And what is this force? This force is called the centripetal force. And later on in the coming chapters, you'll learn how centripetal force is connected to gravitational field and electric field. So for now, you only need to know that centripetal force is mv square over R. And you also need to know how to derive this formula. What do I mean by derivation? Well, F equals MA, right? So I would replace A with V square R, and that is called derivation when I replace something with a formula. And F is mv square over R can also be written as F equals to mr omega square. How is this? Because acceleration, as I said, has another formula, which is r omega square. This formula right here, which states acceleration is r omega square. I can replace v with r omega square. And when I do that, I get F equals to mr omega square. And finally, this formula right here, which is S equals to R radian. What is this? It's radian is the angle subtended by an arc at the center of the circle when arc length and radius are equal. So R here is the radius of the circle. This angle is the angle of the arc. When I make an arc, the angle that I get is this right here. And S is the length of the arc. So this length right here is called the length arc, and it's represented by S. So for now, these are the formulas that you need to know. The first one is time is angular displacement over omega or angular velocity. And then omega is 2 pi f or 2 pi into frequency. And you also need to know this formula right here, that omega or angular velocity is 2 pi over time period. You also need to know velocity is angular velocity times radius or omega r. And acceleration has two formulas, which is v square over r and omega square r, right? Acceleration has two formulas, so you need to know both of these formulas. And similarly, force also has two formulas, which is F equals mv square over r, or simply m times velocity squared over radius. And the second formula, which is force, is mass into radius into omega square or angular velocity. So both of these forces are known as the centripetal force. And I'll explain what centripetal force is later on, but this is the formula that you need to know. And also, the arc length equals the radius times the angle of the arc. So this is the first part. And coming to the second part, right? Now, what is centripetal force? Centripetal force is the resultant force which compels an object to move in a circle. So let's say that I have a car, right? I have this car that is moving in a circle. Now, the force that will pull the car towards the center is known as the centripetal force. And if static friction is less than the centripetal force, the object will skid. What do I mean by this? If static force, or simply the friction force, the frictional force, if it is less than the centripetal force, so if frictional force is less than centripetal force, the object will skid. For the object to keep rotating, the centripetal force, or simply I can write Fc, which means centripetal force, must be greater than the frictional force, or Fr, the resistance force or the frictional force. Both are the same thing. So centripetal force should be greater than frictional force or resistance force so that the object will keep rotating in a circle. Now, always the frictional force provides Fc. So when an object rotates, right, the frictional force Fr is always equals to the centripetal force Fc. What do I mean by this? Well, so when a object moves in a circle, right, the frictional force would cause the object to move in a circle. This means that the friction force equals the centripetal force. For exam, remember that the friction forces provides Fc, and static friction or resistance force has a formula as well. So Fr is equal to velocity into W. This W is called the weight. Weight of an object is also known as mg, right? W, or weight, is known as mg. So when I write the resistance force, I can replace W with mg and I get Vmg, which is another formula, which is the formula for Fr. Now, angular displacement, right? Coming back to the topic, angular displacement, I know, is change in angle in radian of a body as it rotates around a circle. So what is angular displacement? Angular displacement, I told you, has the symbol this right here. I don't know what this symbol is called, but this is the symbol for angular displacement. And angular displacement is the change in angle in radian of a body as it rotates around a circle. So the distance when the object is rotating around the circle is called angular displacement. This you don't need to know because they won't really test you for this. And so let's do a question, right? Let's do a question now. A bird flies in a horizontal circle with the angular speed 5.25 and radius 650 meters. Calculate the linear speed of a bird. Now, what do I mean by linear speed? Linear speed simply means v velocity. So what was the formula for velocity? Velocity, I told you, was omega r. And velocity, we need to find the linear speed, right? So I would replace the subjects now. So 650 is the radius, right? The radius is 650. Multiply this by the angular speed, omega. So the angular speed is known as omega. And this multiply by 5.25. And what do I get? Well, so you get 3,400 as your answer. You get V as your answer. But as I said, you won't get these types of questions. This is only an example because this question is has a lot of multiplication. So you won't really get this question. And remember, in the IMAT, you can't use calculators. So calculators are not allowed. Therefore, they will only give you simple calculations. So not this type of questions, but this is a general way of they could give you easier numbers, right? Like instead of 5.25, they can give you 5. Instead of 650, they can give you 6. So simple numbers, but the theory is difficult, not the calculation. Now, part B states what is the frequency of the bird. So omega, I know, right, is 2 pi f. And I have omega, right? Omega, they told me, is I have the omega, right, which is 5.25. Angular speed is 5.25. So I multiply 2 pi f, and from this I know pi is 3.41. 2.5. Yeah, I didn't really do the calculations. You can do the calculation if I don't have the calculator right now. So you will do the calculation. So omega is 5.25. I know pi is 3.14, I think. 3.14, right? Pi is 3.14. I'll multiply by 2 and I can get the frequency. So if someone can give me the answer, again, you can't use the calculator, so you must know how to do the calculation part. But again, this is a hard calculation, so this won't be really present in the IMAT. So you'll get some frequency, and that is the answer. Again, as I said, they won't give you these types of calculations. They will, instead of 5.25, they can give you 5. And yeah, so what you need to know is the value of pi, which is 3.14. So you'll get some frequency, and that's the answer for frequency. Now, moving on, right? So what someone said 8.13. So, right, yeah. So frequency is 8.13. Great. So let's move on. Now, let's say I have a ball that is attached to a string, and the string is at the center. So the ball is moving in a circle, right? So it's moving in a circle like this. Now, when it's at the lowest point, right? So when the ball is at the lowest point, meaning when the ball is hanging, right? It's hanging like this. I told you earlier that the centripetal force Fc provides the resistive forces. So what are the different resistive force I have right here? Now, I have Fc provides Fr, right? The resistive forces. Centripetal force provides the resistive forces. So Fc equals Fr. Now, what are the resistive forces I have in this occasion right here, when the ball is at the lowest point? So I have tension, right? Now, let me tell you a little about tension. So tension are present in ropes and strings, and basically anything that can stretch will have tension, and tension will always be in the opposite direction. So it will be in the opposite direction to the object. So for example, if I have, let's say, a ball, and it is attached to a string, and this string is fixed to a wall, the tension would be pointing in the opposite direction to the object. Now, in this case, the object is the ball. So tension would not be in this direction, but it will be in the opposite direction. So tension will be upwards. All right. And similarly, in this case, tension, since the ball is right here, tension would oppose the ball or the object. So tension will point in the upwards direction. So tension T is like this. And there is another force right here that is called the weight of the object. So this ball will have weight. And I told you earlier that weight is equal to mg, and weight of an object. So this was one thing. Tension in the opposite direction. The second thing you need to know is that weight will always point in the downwards direction, in the downward direction, no matter where the object is. So let's say the object is going on a slope. The weight of the object would be this way, because this is the ground, right? This is the ground, and the weight will always point in the downward direction. So if the ball was going like this, or the ball was going downwards, if the ball is going upwards, in all of the cases, weight will point in the downward direction. Weight will point in the downward direction. So in this case as well, weight is acting downwards. Now, I know that my FC will provide the resistive forces. So what are the different resistive forces I have? I have the tension and I have the weight. So I will write FC equals to, how can if ball is moving upward? What? How can if ball is moving upward? Wait, how can, okay, I get your question. So you're saying if the ball is moving upwards, how will there, the weights will be downward, right? Is this your question? Yes. So, yeah. Now you're asking if the ball is moving upwards, right? How will weight point downwards? Now, what is weight? Can you tell me? Weight is mass into gravitational field, and gravitational field is the field of our Earth. So gravitational field always points towards the Earth. So the core of the Earth will provide the gravitational field. So gravitational field will always point towards the uh, towards our center. So even if you're moving here, even if you're going upwards, right, this is the surface and this is our center, because suppose this is the Earth, this is at the surface. So the weight, because gravitational field acts downward, the weight will also act downward, because weight equals mg. So even if you're going upwards, the weight of the object, right, the weight is a force. Remember, weight is a force, and this force will always act downwards. This is so if you jump in the air, right, so if a person jumps in the air, right, why would he come down? Because of his weight. Because weight acts downward, the person will eventually hit the surface. That is the reason weight acts downward. Is this clear? We are applying force on ball to make it upwards. Yes, we are applying the force to make it go upward. And suppose, what do you, I get your question. So you're saying that this plane, suppose there is a plane and the plane goes upwards, right? What is causing the plane to go upwards? It's the force of the jet. So the force of the engine, right? The engine force provides the force that will go upwards. But this plane will have the weight, which will still act downwards. Now, this weight will act downwards, but the force that is causing the plane to go upwards, right, is the engine force. Engine force. So the point that I'm trying to say is, when something goes upwards, that force which is providing it to go upwards must be greater than weight, so that it goes upwards. So if this object has weight, this plane, let's say, has weight this much, then this would be the engine force. You can see how big the engine force is compared to the weight of the object. So any object must have the upward force greater than the downward force, so that the object will move upwards. All right, you got it. That's good. So moving back to the topic, where was I? Yeah, here. So I was saying that the frictional, the centripetal force equals all of the weight, all of the resistive forces, which are the weight and the tension. Now, which direction is tension pointing towards? upward or downward? It's pointing upwards. And remember, upward, since force is a vector, forces are vectors, right? Forces will have direction. So direction will matter here. So since tension is upwards, upwards is positive. So I write tension as positive. And weight, right? Mg equals to weight. Mg is in the downward direction, so I write Mg as negative. So tension minus the weight of the object would equal the centripetal force, right? So tension always points away from the object. In this case, it's upwards. So tension here, it's positive, right? So Fc equals T minus W in this case. Now, this is when the ball is downward. But what if the ball is in the upward direction? Because I told you earlier, the ball is spinning. So it will go, it will come down, it will move here, and then it will go upwards again. When it's upward, right? What is FC? FC is still equal to the all of the resistive forces, right? And in this case, when the object is upward, the weight will act downwards, right? Weight will always act downwards. So the weight of the object will act downwards. And what would be the tension? The tension of the object would be upward or downwards. Can someone tell me in the chat? Will tension be up or down? Tension would be down. Yes. Why will it be down? Tension would be down because tension always will be opposite to the object. So this case object is here, tension will be in the opposite direction, so tension is downwards. Now tension is downwards, weight is also downward, right? So let's say that I take this as positive, this as negative. The positive direction is going upwards, the negative direction is going downwards. In this case, my tension is going downward, right? So tension would be negative. So tension is negative T. Weight is also downward. So weight is negative T as a negative W as well. So weight is also negative. Now, when these two negatives, they come together because negative plus a negative gives me positive, right? So when these two come together, I get FC as T plus W. And when the object is at the top, this is the formula that you will get. Fc is T plus W. So this is the type of question that can come in your exam. They'll give you two scenarios and they'll tell you to make a formula. And they'll give you options like if this is Fc is T plus W, T minus W, T multiply W. And if you know the concept, then you can answer the question. Now, one thing that I want to make clear is that tension is always more in the downward direction. So if the object is attached to a string and it's downward, right? It's at the bottom, at the lowest point, the tension right here would be much greater compared to if the ball was upward. So if the ball was in this direction, then tension here would be less compared to this when the tension, the ball would go down. So tension at the lowest point is much, much greater compared to the tension at the highest point when the ball is at the highest point. And remember, at the lowest point, tension and weight are opposing. So when the ball is at the lowest direction, when the ball is, wait a minute. Yeah. So when the ball is in this direction, right, the tension is upward, weight is downward. The weight is downward, tension is upward. At the lowest point, tension and weight are opposing each other, right? Because this is a force and this is a force. They both are opposing each other. Weight is opposing tension, right? What if it's linear to center? What if it's linear to center? I don't get your question. Are you saying if it's like this, if the ball is in this direction? Yep. All right. So I'll explain this, but let's finish this first. I'll get to you this question. But when tension is opposing weight, right? Meaning at the lowest point, the tension opposes the weight. This point is the greatest point where the chances of the rope, this rope right here, when this ball is attached to the rope or the string, right? This, when it's at the lowest point, this is the point where the rope has the greatest chance of breaking. So the breaking point of a rope is greatest when it's at the bottom. So when it's at the bottom, it has the biggest chance of breaking. The rope will break the most if it's at the lowest point because tension and weight are opposing each other. Now coming to your question. So you're asking what would be the case if the ball is right here. So the ball is 90-degree to the string. This is my first physics class after 10, so please make me correct if I will ask anything makes sense. Yeah, it's not any problem. Don't worry. I'll explain everything. So when it's like this, right? You tell me which direction would the weight be in? Will the weight be right, up, down? What will be the direction of the weight? You tell me. I only have 3 minutes left. 4 actually. So the weight, if you don't answer now, I'll answer myself. Weight is acting downwards in all cases. Seems like it at the center. No, I told you earlier, weight, which is a force, will act downwards in all cases. I mentioned it here as well. It doesn't matter if the if the object is moving up, down, center, the weight will always be in the direction of downwards. So weight in all cases would point downwards. I mentioned it here as well, somewhere here. Yeah. Weight is always in the downward direction. Doesn't matter which case the object is in. So it doesn't matter if the object is pointing upwards, moving downwards, the weight will always be downwards. Now, tension would be in which direction? Can you tell me the direction of tension in the rope? Towards what? Towards ds what? Towards the point. Do you mean this point? Yeah. So will tension will be in the opposite direction to the ball. In this case, tension will point away from the ball. So this way. So this will be the case if the ball is at the center. So when I make the forces right, tension like this, weight like this is the force that I get, the forces. Now, resultant force of these two forces. What would be the resultant force of these two forces? Right? So tension moves left, weight moves down. When I make the resultant force, it would some way look like this. Hypotenuse. Yeah, this hypotenuse would be the case for the resultant force. So the tension moves left, so and the weight moves down. And when I make the resultant force will be this force right here. So this is the resultant force. And this force is 90 degrees to these two forces. All right. So do you understand this concept that the tension would be towards left, weight would be towards down. Okay, good. So that was today's class. I hope you learned something well, and I'll see you on Sunday. Goodbye.